Exploring transformations, and transformations are the art of moving a function around in space, either moving its location or changing its shape. And without knowing it, you've probably been doing transformations for a fair while. For teaching transformations, we'll just look at x squared quite a lot and x cubed, but these rules work for all types of functions. It's just worth considering one we're very familiar with to start with. And in terms of just making sure we're familiar with it, I'm sure you'd all be happy if we had that written down. So these are these x, y values. If we square them all, that's what we get, and that's what gives us our curve. At -3, it's 9 high. At 2, it's 4 high. Alright, so now let's consider what happens if we have f of x plus 2. So what we're looking at here is what happens when we take a function and add some constant to it. That's a. And if we know what happens when we add, we can probably also figure out what happens when we take off. So what does this look like in terms of the numbers, and what does it look like on the graph? We'll see in a sec. If I add 2 to it, are you happy that that just becomes 11, 6, 3, 2, 3, 6? And so the points are all exactly the same, but the whole thing moves up 2. So if I have x squared and then add 2 to it, I get the same graph, but we just say it's been translated up 2. And you guys would be pretty happy if I said -2 drops at 2. Yeah? So this is our first sort of transformation. Plus or minus a, and there's fancy green notes at the top and there's summary notes at the end of your sheet. You don't have to write too much down. Plus or minus a just moves it up and down, plus and minus, exactly as you'd expect. However, the next one is not as predictable. What I would like to look at now is f of x plus 2. So what that means is, we're not adding 2 onto the end of the function, we're putting in the original x value and then 2 more. So, can anyone guess what will go here? 25, nice. Because I'm putting in, no, not 25, bad. -3 plus 2 is -1, so 1. I fully agreed with the 25, so that sounds good. No, -3 plus 2 is -1, so 1. -2 plus 2, 0. 0 squared is still 0. -1 plus 2, 1. Because I didn't square it. 0 plus 2 squared is 4, 9, and here's our friend 25. Okay, now we sort of recognize this pattern. It's this 4, 1, 0, 1, 4.
Is it
but
16?
the whole...
Yeah. 16. 16.
Good.
That's not turning.
Wait, who called it first? Have we done the Mentos thing with this class yet?
Not yet.
Okay. So, the deal I normally roll with my test classes is, if I make a very careless error, whoever points it out, because you're paying attention, gets some Mentos.
It's you!
And today is going to be a Mentos-rich day for you guys. Well, one of you. Alright, so yeah. 4 squared is indeed 16. We recognise this pattern, and it has moved. It's no longer zeroing out at 0 where the original x squared is. Instead, it's zeroing out at -2. And that makes a little sense, because for us, f of x plus 2 is the same as x plus 2 squared. And I'm sure you're all thinking, okay, the value to make this whole thing 0 is -2, so it will zero out at -2. And therefore the graph looks like this, bracket, x take 2 squared. So the graph has moved across. No, I said take 2, it moved wrong. Plus 2. Moved across. So it's a trap. A plus 2 in the brackets. You're thinking plus, positives this way, it should go this way. But it doesn't, it's a trap. A plus 2 in the brackets means that you'll turn it, in this case here at -2, it's moved 2 in the opposite direction in which you expect. Does that make some sense? That Yeah, the up and down one, beautiful. You add a number, it goes up, you take a number, it goes down. This one is the opposite way in which you'd expect. And you can sort of convince yourself more of that if I put an A in here and then add a slider. And as I drag it to the right, it moves left. And as I drag it left, it goes right. So, the second part of our notes might read f of x plus or minus a has the impact of translating it horizontally, but it's the opposite of what you'd expect. So plus a actually gives you this direction and minus a gives you that direction. And that green box at the top of your notes is basically explaining that. Alright, so let's look at question 5 in the notes. It's the first question I sort of ask you here. Find the equation, the resulting graph of f of x squared translated through hk. Now, hk, you probably would have seen that before. It's vector notation, but this is the x coordinate and this is the y coordinate. So if you want to move the graph y equals x squared or f of x equals x squared through hk, what that would look like is f of x plus h, or if we want to move it to h, we take h, plus k. So we're translating across and up, and once we sub that into the function, this will look like x take h squared plus k. And do you guys recognize that form? Turning point form? You did quadratics last year? Yeah? And you know, or vertex form? You could, from that, you could have picked the vertex hk. Yes? Maybe? Year 10 was a long time ago?
Yeah.
Yeah? So what that's saying is if I have x take h squared plus k, h takes me left and right, k takes me up and down. Cool. Alright, let's do the next equation down. So this is probably the first time you actually have to take notes on it. If I've got the graph f of x equals 2x squared take 3x plus 4, and I want it to go 2 to the left and 4 up. So we've got this graph, and you can draw it on your calculator on Desmos. We then want to move it 2 left and 4 up. The replacements we use are, we then want f of x plus 2, because we know that a plus moves it to the left 2, and then I want to add 4 on. And then we're going to sub this into that equation wherever x is, and I'm going to add 4 on the end. So I'll try to do this colours to make it obvious what I'm doing. I'm going to write in 2x plus 2 squared. So I've subbed in the x plus 2 there.
What?
Minus 3 x plus 2 plus 4, and then plus 4. So wherever x is, I've replaced it with x plus 2, and at the end of the function I've added another plus 4. And if we graph this function and this one, they would have exactly the same shape. It would just have moved 2 to the left and up 4. Yes?
Can you graph that and translate it afterwards?
I guess if they ask you just to draw a graph of the translated one, then yes. Often they'll ask you for the equation of that translated graph. So this is the equation of the translated graph. But yeah, you're right, you could just do it graphically if that's what they're asking. But here, they'd expect you to probably expand and simplify. Now, I trust all your math skills, so I'm going to let you guys expand something like that, or I'll end up giving off Mentos. and we can move on. Actually, I'll give you a second to expand it. So I guess I should do it. What's that? 16. Don't trust me, you gotta do it yourself. And then if you do finish, look at this graph compared to that graph, and you should notice that move that you wanted. When you've done that, can you guys have a shot at the questions on the bottom of that page? I'll interrupt you as we go through the lesson to keep going through transformations, but it's worth just practicing those movement ones first.